my name is Timothy Williams, and I'm here with Mr. Ajit Ninan, the Vice President of Engineering at Dolby Laboratories. So, can you please tell me more about what this room is about here that we're in?
Yeah, sure. So, we're in a lab that's also a theater, and it's a multi-million-dollar installation that's actually designed for us to be able to do audio and video testing and quality assessment, and once in a while we'll watch movies in here as well. It's been designed so that we can do spatial audio and high dynamic range video. We actually have a very expensive laser projector in the back over there that's capable of a lot of power, and because it's a lab, we actually have to be laser certified to be able to operate this. So it's a very interesting room.
Okay. So, what do you think are the main challenges in live VR streaming?
So live VR streaming, in order for VR to be realistic, you got to achieve what I believe there are 9 aspects of VR imaging that needs to be done right. And I don't want to go into each of these too detailed, but I'll give you a really high-level view of some of these important ones. So one, as Dolby, we push the technology called high dynamic range imaging into the market. So for VR to look realistic, you really need to have high dynamic range and high contrast, and that's what allows the human eye to be able to distinguish between objects with color and contrast and fidelity. And so we think that's a very important aspect, but there are other aspects as well, such as the field of view and the resolution. And so for field of view, what we're talking about in VR is typically you want more than what you see on a TV, which is only 48 degrees. You want to be able to go to all the way to 110 degrees. Humans can see 220 degrees. So the closer you get to that, the more immersed you feel. But you have to treat that image carefully when you give that much field of view, because people can get sick pretty easily if you're not careful. The other aspect of this is stereo vision or 3D. And the way people see 3D is different for each person because we have different spaces between our eyes. And so recreating that 3D correctly is really important. And then I mentioned resolution, which is basically how clear you can see each of the objects that you're taking a picture of. And if it's very low resolution, it's hard to focus on, and your brain takes a lot of energy to try to distinguish what objects are. So you need really high resolution, or what we call 60 pixels per degree. In your eye, if you take 1 degree, you need 60 pixels of light to hit in that 1 degree. So that's pretty high resolution. So if you start thinking about all of these things, the amount of data that you're streaming can be really large. And so for VR streaming to happen effectively, you have to have very high bandwidth. And when you have high bandwidth and you're trying to stream this to a remote location, latency becomes a problem. So if you have a camera that's only doing 220 degree field of view, if I turn my head and it takes a second for the image to turn, that can make the user sick on the other side. So sometimes what we do is we capture all 360 degrees, and we just give the user the right view that they're looking at. But with 3D stereoscopic vision, you have to have 2 cameras, and they have to be offset at the right spacing. Otherwise, it doesn't feel as realistic. And also, there's something called 3 degrees of freedom versus 6 degrees of freedom. So when somebody moves left or right, they feel comfortable if the image moves with them in that kind of a spatial orientation as well. I mean, it really depends on how far these objects that you're interacting with. So if you're really close to me, I need the objects to stay persistent. But if you're really far away from me, if I move back and forth, a mountain's not going to move that much, so it doesn't really matter. So these are some of the challenges for video VR that needs to be taken care of. So it really depends on what you're going after in terms of the video side of things. But latency, frame rate is another one. So how fast the pictures are updating in your headset, and how fast it updates when you turn and respond latency as well. So those are the things that you need to keep an eye on. So, yeah.
Okay. So, how does directional sound work with VR?
So directional sound so spatial audio, as we call it, is really important in VR. Because if you're wearing just a set of headphones and you're looking at an object that's in front of you, that's great. You can represent it by playing back in both the speakers on your headphones. But if the object is over here and I turn to look at the object and it's always represented in my left ear, and I turn to look over here and it's still in my left ear, and these two don't match, it creates a cognitive load for the user, and they get confused, and it can be disorienting. So what you want to happen is if the object is here and you hear it on the left, when you turn, it should remap itself. So you have to keep track of where your head is at, and then you have to re-render the audio. So you can't just do what you call just plain stereo audio. You actually have to capture what's called a sound field. So you need multiple microphones, and you need to capture that sound field, and then you have to render it in a correct way for the way a human is in that environment responding. Plus, also, you have to play it back so that people can feel like it's in the right place based on how far apart their ears are and how your face and everything is designed. There's something called a head-related transfer function, or binauralization, which creates that feeling of an object being where it's at. So a couple things that you have to take care of there for it to feel right, and why it's important is because of this. People use all their senses, visual and audio, in order to be able to make decisions as to where to look and how to respond to things. And, so both of those are probably the most important of decision-making tools that humans use. Right after that is haptics and things like that, which I'm sure you're going to be looking at as well. So,
yeah. Okay. So, what challenges do you see for Valley Christian School team in achieving the objectives set by the XPRIZE competition?
So your competition is to create some kind of an avatar, and it depends on what the application is. So, the whole thing with haptics and feedback and whatever you're trying to control and interacting with things, there's going to be a challenge there because of latencies. And you're talking about doing some kind of a remote experience. There are technologies like 5G that's going to give you like high bandwidth, low latencies and things like that, but there's still going to be the way a human operates and interacts with things is going to be completely different. So how to make that experience comfortable, I think, is going to be the biggest challenge. On the haptics side, if you try to get too realistic with your hands and interacting with your hands and creating something that matches exactly the way your hands move, it could actually backfire on you. So knowing which side to go to, absolute realism or actually disconnecting sometimes the user from just that absolute realism is actually better. So for example, if you're trying to interact with an object and you don't get that instantaneous response, that could be more frustrating than if you just gave somebody a joystick and they can visually see a clamp or an arm or something like that, and they're able to control that. That could actually be a better experience than giving them a bad experience with like high latency, and they close their hands and then they don't feel the right thing, or they over squeeze something and crush it, like if they're trying to pick up an egg, because of that lack of bandwidth or issues with latency. So you have to kind of gauge which extreme you're kind of going to go for all of this, given the set of technologies that you have access to.
Okay.
So that's going to be a challenge for you guys to decide which extreme to go to, right?
Yeah.
Absolute realism, or in some cases disconnected from that to create a good experience, a usable experience. Right?
Okay. So are there any other products or companies that we should look at?
I think, of course, 360-degree cameras. You should look at companies that are doing stereo 360-degree cameras and are able to re-render images. There's a lot of companies out there. I think I saw a company called Views that actually does pretty good stereo rendering of cameras. But I'm guessing that yours has to be portable and movable.
Yeah.
So something that's compact that still gives you, instead of just a flat 360, a stereoscopic 360. So I would look at that. And then, of course, capturing audio. You want to look at XY microphones. There's quite a few of these that can actually capture, a sound field. And so, Dolby has some technology around there as well in terms of capturing and being able to create that sound field. And so those are the two areas that I would actually focus on mostly, is the image capture and the sound capture. On the haptics side, there's multiple companies as well, but knowing that this is a remote experience, I would suggest that you focus on traditional methods of interaction, like joystick or something like that, and whatever the interaction devices that you're going to be using is a little more simplistic in that sense, because we're not advanced enough in technology to have that type of access. So I'd look for companies that are a little bit more simplistic in that area, but focus on the audio-visual aspect with high quality.
I see. Okay, so thank you for your time.
You bet.
And that concludes it.
All right, thank you.